Shut up and sit down.
Hello everyone, welcome to Monday Night Project. I am Kicad. Tonight we're going to be looking at building a circuit board with Kicad, and the circuit board is for my HardSense project. Now if you're new to the stream, welcome, and if you're returning, hey, thanks for coming back. But if you're new to the stream, welcome to the stream. Go ahead and subscribe, we got some interesting things coming up. But on tonight's stream, quick little preview of what's going to be happening. I want to go ahead and finish building this circuit board that we can see for the HardSense project, and that you've already noticed the camera that's running in the top corner and the one that's running in the middle. We need to build a circuit. I need to build a circuit board for that. Now I've already done a lot of early work and I built this, and I'll show you it some more in detail. Now I can't really use this, but if we have a look at what it'll look like in real life, we can see a beautiful little 3D rendering of it. Now I'm going to go ahead and have to do a lot of rework and redesign to make this work for me, and that's what we're going to try and do tonight. Sorry, there we go. This is the circuit board that I'll be working on tonight. Now I've already gone ahead and done a lot of work on it, but I can't really actually use this design simply because I'm going to be making this circuit board at home. And a lot of these lines are just too fine and too close together. So I've already printed this out on a piece of paper. And you can see those lines are really fine. They're going to be very hard to actually work with if I do this on a home created circuit board. So to that end, we're actually going to redesign this circuit board and make it a little more user friendly for those who are going to make it for themselves at home. Now, you might be wondering exactly what is the circuit board going to be. Well, let's have a closer look at exactly what's going on in this top corner. You know what? First of all, HardSense, the project encompasses two particular sides to it. First of all, there's the HardSense 64 application, and this application runs on your Windows computer. This is just kind of the stub out for the front end of it. There's still more work to do on this side of it. Right now, the important bit is that it just sets up a hardware monitor. Well, I know that camera's going to be a bit bright, but deal with it, sorry. It sets up a hardware monitor for monitoring all of these sensors and keeps track of that information by updating a memory mapped file. It also, once it's set up that hardware monitor system, it will then create a TCP server, which is capable of monitoring a port and spawning off new clients that are connected. And those clients can then request a list of sensors to be streamed to it. And that list of sensors can be stopped, or it can be switched to a different set of sensors at any particular time. But the more fun part of this whole project is the one that you can see right below me. Let's go have a better look at that. This is the HardSenseESP side of things. This is the electronics. If we take a slightly wider view of what's going on here, you can see on the right side of your screen where my hand is, this box is going to be approximately the size of the finished HardSense project, or a product. Why is that screen going all colorful on me? Okay, well that's going to be annoying. So this is going to be approximately the final size of what this project is going to fit into. And in fact, the final step of this project, which I'm hoping to do within the next 2 weeks, is to design this box for the HardSense project in Fusion 360. I don't know why my camera is doing that, but I hope it's... well, maybe try if I adjust this light a bit. There, hopefully that works a little better. Now, so that's what the final HardSense project is going to be. But today we're dealing with just the microelectronics. And if you look at the top right of your screen, again where my hand is, you can see just exactly how big these little screens are and how big the microcontroller is. Now, if I look down here, where is it? Right here. I actually have one of these microcontrollers. This is a slightly different model than the one I'm using right now. I don't know why I didn't bother to get out the right one. But this is an ESP32 microcontroller, and you can see how big it is. The display that I'm using right here, we'll center that a bit more for you, is one of these. It's a little 2.8 inch TFT display that you can buy pretty much anywhere for around $10, I think. But you put them together along with a few other bits, like a button. This is a real-time clock, so it's using the I2C interface. And then this is a rotary encoder. Now this rotary encoder is actually going to be using just the, it's also a push button, but it's not, I'm not using the button side of it, just the rotary part of it. Pardon me. I'm sorry, you're going to have to excuse me for 1 minute. This is so horrible for me, but I got to go open a window. For some reason, it's getting really warm in here. I'm really sorry about that. We're going into a cold snap, and it's even started snowing. So, you know, the temperature wants to, or the thermostat wants to, you know, you just open a door, and all of a sudden things just go weird. It takes a while for things to get normalized. But anyways, let's have a look at what's going on. Oops. I do have a problem with my power supply, apparently. So this is HardSense ESP. This is what we're actually building the circuit board for. So we have the ESP microcontroller right here. Let's get my focus back. Sorry, stuck my hand into there. There we go. The encoder, the button, the I2C interface for the real-time clock, and then of course the TFT display along with its touchscreen. So there's a whole bunch of pins that actually need to be accounted for. For example, here we go. Let me get it the right way for you. This is what it looks like on the back of that board. And if you want a closer look at exactly what I'm using here, it's one of these. See if we can get some focus on that. There we go. And you know, they're fairly inexpensive, but they're all right. They actually work pretty good. Now, my camera does not do these justice. So what we're seeing here on the home screen is we're seeing information streamed from my computer. This is the CPU loads, temperature, wattage, power, clock, speeds. The same for the graphics card. Along the bottom, you'll see the basic usage for my hard drives. And then we have some network speeds, and of course the system RAM. Now, what's really cool about this is it is a touchscreen, so I can touch my GPU panel, and I can go in and get a much more detailed look of what's happening with my video card. Here we have the 90-second graph for the fan and temperature, a updating power or a load monitor. The RAM is, of course, for the video card RAM, and then some more basic information that I like to keep around for when I'm gaming, the network speeds for up and down, an FPS monitor, and my CPU monitor. We go back to the main screen. Up here we have our CPU panel. This divides my processor into individual cores. It is a hex core, so it actually has 6 cores, but if you look in Task Manager, you'll see it has 12 processors, or 12 threads, but it's actually 6 physical cores. That's why we see the 6 here. Now, I've been working overtime in order to get one last really cool feature finished. So if we actually hold this button, now the final box, this button is actually kind of going to be hidden in the back. Now if we hold this button down, when the firmware boots up, it detects that the button is actually pressed, so it launches us into the configurator mode. Now I do have to fix the font sizes and whatnot on this particular screen, but it's not a big deal. But the reason why I'm free to go ahead now with the circuit board and the final enclosure is because I've finally finished this functionality. We have what's called OTA, So if I touch my OTA panel, you'll see it switches over to this. Now, let me show you. First of all, it is in fact connected to the Wi-Fi network, and you'll see this listed up here, SSID, star side. So that's the name of my network. The only other wires connected to it is, of course, the power supply, and then these two lines, the black and red, which are connected, of course, to the oscilloscope, and I'll talk more about those later. But while it's in OTA update status, it's actually just waiting to be connected by a client. So we can actually go find my VS Code client. Where are you? Oh yeah. There you are. Now, just to show you real quick, let's clear the bottom text. Make sure that auto scrolling is on. I'm going to go ahead and upload a new set of firmware. This is the software I would normally use to upload firmware. But if you look on the right side of the screen, you'll see that it's still in OTA update status. And it is not plugged into the USB, so it will be doing this over network. Now we just have to watch what's sort of happening at the bottom of the main screen down here. I'm going to click the upload button, which is hidden by my face. And there we go. So this starts the build process. It's going to go ahead and verify all of the source files are fine. There's a lot of them. And then we're going to see it actually connect out to the network. At which point, keep an eye down below. We'll switch real quick over to a close-up again. You'll notice it says OTA ready and waiting. OTA stands for over the air. And then we have that little ball that's just running off to the side to let us know that it's actually running and that it's not stalled, and we're getting that nice feedback. So you can see down here at the bottom we're still verifying. We'll start the upload in a minute. It does take a while. This is why I'd really like to use VS Code. VS Code is so much better, but there is a license that has to be purchased with, not VS Code, Visual Micro, which is an extension for Visual Studio. But Visual Micro is a wonderful environment. Here we go. So it's starting the update now. Check it out. Oh, it now says OTA is running. Do not turn off. So we are actually doing that firmware update. If we go back to the desktop and you look on the bottom of the screen, it's just scrolling to the right, pushing out that dot. You hardly know what's going on. So we're getting this feedback from the machine itself, letting us know that it's actually doing an update. Look at that go. Doing a wonderful update. So it's just about finished. Update is completed. There's an automatic restart. Boom. So I can now do firmware updates. I can now do firmware updates to the HardSenseESP remotely without having to plug in a USB cable, which is wonderful. Now that means I can actually go ahead and take the next step of building a circuit board and isolating the whole unit into a box, and I can continue with the code development in a much more relaxed manner. So that's what we're going to do right now. Let's pop over to Kicad. Okay. Disclaimer number one, I'm no expert in anything. I don't know what I'm talking about. I've learned everything I can over the last many years, but that's it. Don't trust my advice. I'm telling you right now, I don't know anything. I'm not endorsed by anybody. Disclaimer number two, I'm not affiliated with anything. Everything's my own opinion. Nobody's paying me for anything. There's nothing going on. No ad money. This channel's not monetized in any way. So this is just me wanting to show off my little project that I'm hoping to share. So that's HardSense in a nutshell. We have the touch screen, the multiple displays, a volume encoder, a button, and a real-time clock. So if we actually come over here, first of all, let's just have a quick look at our schematic. Now, we are in fact making a circuit board, which means getting into some electronics and doing some little electronic work, but thankfully this is a relatively simple board. Now, in order to actually do some of the work we're going to see, where is Firefox, there it is. We need to talk about my GitHub repository. So github.com/kitecraft, and we're working on the HardSense project. So from my GitHub, yeah, you don't want to see that. You can just go to my repositories up there and then click on HardSense. But for what we're working on today, you're also going to need Kitecraft's Kicad libraries. Down at the bottom here, there's another link called Kitecraft's Kicad libraries. This contains some of my own symbols and footprints that I've designed specifically for the ESP32 and for some connectors. So in order to use my design files, you're actually going to need some of these templates as well. But we can go back to the HardSense project, and everything I'm working on today is being done in branch 20, update the PCB. So everything I'll be working on tonight will be checked into this branch of my GitHub repository for HardSense. Now, what do you say we actually go have a look at that? Schematic. So we'll zoom in a bit here. So right here in the middle is my dev kit. This is the ESP32 microcontroller, the one right there. These are I like to lay these out the way they are physically. I am no design expert. I don't do this. It is much easier for my brain to get wrapped around it by actually having my schematic for the component laid out like it is physically with those pin orders. It just helps me do what I'm doing because I don't build complicated circuit boards. This thing is this circuit board it has the ESP32 microcontroller, but that's actually going to sit on headers. I'm not going to be soldering this microcontroller directly to the circuit board. I'll actually be using a set of female headers. And then over here, these are all just header connectors that will be used to connect wires to the actual components. For example, this is the connector that goes to the TFT controller. You know that big bunch of wires you see right down below here? This bunch of wires that we see right here in this area is represented just by, where'd it go? Whoops. It's represented just by that bit right there. And then of course we have the button. This is just a jumper, a connector for the RTC, which is using the I2C interface, and the volume encoder. Like I said, I'm not using the actual button. That's because in the final box, it's not going to be held as a rotary knob. It's actually going to be laying on its side and act as a roller. So there'll be a 3D printed knob around it that you can just roll. It'll be cool. So again, this is a very simple circuit board. And of course here we have some mounting holes. Now, this board does not have a power supply built into it. We just have a simple connector, a 2-pin connector. We have, whoops, I moved it again, didn't I? Yeah. And a capacitor. We're going to want a capacitor here on this board because it is going to be supplying power to this microcontroller and then of course out to all of these other components. So the power source is going to have a small little wiring away from it, but that's okay. Now this video is not about making or designing this circuit. It's about finishing off the actual circuit board. Now, the design I made here, I was trying to keep things tight and I was using just a default trace widths and whatnot. And I was thinking about if I wanted to send this PCB off to a manufacturer and let them make it for me as a dual-sided PCB, you know, what would be the nice way to do it? You know, I'd have the nice thin traces because they're going to be properly covered and, you know, all of that. But I'm making this circuit board myself, so I can't afford to have all of these really delicate traces because, like I said, look at this. Here, I'm going to show you what this looks like on the other camera. So you can see how fine those lines really are. And since I have to manually drill all those holes with my own drill press, if I make one little mistake, I'm screwed. So I'm going to refine this circuit board to something that's a little more user-friendly for the home builder with big thumbs like myself. So first thing I'm going to do is I'm actually just going to delete pretty much everything. Now this is not a tutorial in how to use Kicad or anything like that. So I'm just building my project, and I'm hoping people will join in and you know, chat about it and take an interest in HardSense as a project. But don't expect me to be teaching you too many tricks about what's going on here. However, when we get to making the circuit board, I will show you some neat tricks about how to make your own circuit boards. Okay, so let's delete a bunch of these lines here. Whoa, that was not the right line to delete. Okay. You go away. You delete. So I'm just going to try and delete all these traces without deleting anything important. Whoop, like that. Yeah. You, okay. Now let's get some over here. The reason why I'm deleting all of this is because I just intend to move these components around. I want to give them better spacing. Right now, oh, you know what? Before I do that, let me show you. So for the final circuit board, I'm not too concerned about making this as tight and as small as possible. That's not a big deal for me. If the circuit board is actually, you know, come on, move for me. There we go. You know, if it's actually that wide, I'm okay with that. I really am. So that's not a big deal. You can see that this is actually going to be a fairly nicely sized circuit board anyways. I mean, you can imagine, the reason why everything here is just on pin connectors is because this button won't be on the circuit board. It's actually going to be a different type of button that'll be attached to the box itself, and then just has two wires coming off the back that'll get plugged into the pin. This is going to be much easier to mount separately. To try and make a circuit board big enough to accommodate the real-time clock will then just create an unnecessarily large circuit board, especially when this can just be mounted by itself somewhere else. Oops, I just messed with my power supply again. The volume encoder is definitely not connected to the circuit board. It will not be mounted on the circuit board. So the only thing that is actually mounted to the circuit board is the microcontroller itself. So yeah, I don't need a lot of small space for this. The whole power system is actually coming from a different circuit board that's called the P board. And that's a whole different project I'll be coming up with, but I'll be making that circuit board at the same time I make this circuit board. And if you want to see what that actually is, go back to my other repository called P board. And I think we have some pictures of the P board. The P board is my power board. And the circuit board can be used for either a 5 volt or a 3.5 volt switching voltage regulator. But it makes, whoa, darn it, sorry about that. I wasn't showing you the right thing. Again, I keep screwing that up. So, my circuit board here for the HardSense project doesn't have any power on it. The power actually comes in over here. You can see this little connector. Whoops, there we go. You can see that connector there. And you're familiar with that connector. You know what that connector looks like. So the power will actually be coming into that from my other project called the P board. And the P board can be mounted separately. And this is actually a 3 amp switching voltage regulator. Here's a small inductor. It has 2 power outlets and 1 power inlet, or input, 2 power outputs. So that will make for a nice power supply. And one of the reasons why I'm doing it this way is it actually makes it easier to create a smaller, more compact finished box, because now you can mount the circuit board on one side, the power supply on another side, the real-time clock over here. It'll be much easier to fit everything around. So I got to first of all just make this board easier to make. And so let's go ahead and just delete all those traces. Oops. Again. Nope, not that way. There. So delete it. No, stop doing that. I don't want to delete you. I want to delete the traces. Thank you. Don't delete components. Please don't delete components. I just want to delete all of my traces. The reason why I'm going to do this is I'm going to I'm going to move them. So things like this would never work on a homemade circuit board. Not for me anyways. I got to use big fat traces. So I'm going to have to move this component all the way, move that trace all the way around the end. It doesn't matter if it's longer. You know, big deals like that. We're not building high performance boards here for myself. That's good enough. And I'm going to give myself a little bit more space in between these connectors. That way I can actually just use fatter traces, which means I can drill, the holes that I drilled can, you know, might be just a bit off, and that's okay. So we'll just keep deleting these existing fancy traces. Get rid of this one, get rid of this one, get rid of that, get rid of that. Oh, I wish I knew a faster way to do this, but I don't. There. Some more over here. Okay, almost got them all. There's one. Now let's see here. Is that all of them? Nope. I could probably almost keep those, but I'm going to get rid of them. Okay, so all of my traces are gone. Let's just save this. Now, it really didn't matter to my board, did it? No. Okay, now I'm also going to go ahead. I'm just going to move these. First of all, let's change my grid. I want to change my grid. So normal is 1.27. I like to have that, which is 0.635. I'm just going to move you. Why aren't you, thank you. Just going to get you out of the way for a minute. What are you doing there? Thank you. And I just want to move this. Now it's probably not going to like that over here, right? That's fine. Where'd the other one go? Whoops, that's the wrong layer. Change my layer to the edge cuts. And I just want to move this. I just want to grab this end. Why won't you select it? There we go. And where'd my other line go? I thought I moved it. Did I somehow delete it accidentally without realizing it? I guess I did, didn't I? Oh well, not a big deal. I will just draw me a new one. So I'm just trying to get that border bigger, so that I can just move some components around. That's all I really want to do. Now I got to draw me a new line from there to there. There. Now this won't complain. That's all I wanted to do. That was a lot of work to get that done. Okay, so let's see here. Let's just move this. And the text. The text, I'm just going to get rid of it for a minute. I'm going to move, whoops, you stay there. You, I'm going to move you. Oh, I forgot I did all that artwork. Oh shoot, I really did forget I did all that artwork. Why did I bother to do that? Okay, I'm just going to grab you all nicely and just put you. Where's a good place to put you? I'm just going to put you over here for now, because you. There, now I can grab this. Okay. I'm just going to pull that back a bit, just to give me places to put a nice big fat trace or two. I can move it again a little bit later, but let's put it right about there. That means I can move this pad out to, let's say, there. Move this just to say there for now. No, I gotta move that one further. There. Well, that should work. Is that kind of in the line in the front too? There, how's that? Good. Okay, let's see here, what's this? Oh, that's right, touch. So touch has a, why does it have that one? Oh, that's the CS line that goes all the way to the other side of the board. You see that one that lines up over there? Right. Do I have to leave that one there? You know what, let's check something. This is one of those times where I wonder if I can get it, change that pin to a different pin. Let's have a look. I'm going to open my user setup file. You know what, let's do this a better way for you guys to see. I'm going to go here to HardSense, software, HardSenseESP. So this user setup, this is my setup file for the TFT display. Now there's a section in here for the touch pin. Touch CS. I can move that. I think I've got it on the wrong pin anyways. Huh, see? The bugs you find when you're actually digging into this. Okay, well that's interesting. Sorry, I'm eating gum that's actually nicotine gum. You know what? I'm going to move this to a different pin. You know what that means, though? It means I'm going to have to do a quick change of the hardware here. Hang on. Something's not right. Well, that's interesting. I screwed something right up. Because when I'm looking at my wiring, I don't have any wiring what the hell is that? Power. Now I've got one for the button. I've got one pin for the button, which is this Bluetooth button up here. I've got one for the volume encoder. Well, two for the volume encoder. That's these two right here. But that's interesting. I think I've got some wiring problems here in this schematic. Oh, I gotta quit doing that. I'm using a bad power supply. I think I've got a problem here. I think I've dropped it one too many times. But what I'm looking at is basically the wiring that we've been looking at in the hardware or on the schematic should basically match what I'm seeing in real life. Now you can see on the right side here, the touch controller says it's got a pin going over here to TS7, but in my code, well, you know what, just for the sake of sanity, I'm going to go check the actual file being used, not just my copy of it. Because now I'm bugged. What's going on here? Workspace, or do we know? Where is the library? TFT. Where is it? Oh, libraries, of course. TFT-ESP, user setup. User setup. Okay, so what are we looking at here? Define touch CS is on pin 8. Now if I look at my hardware, okay, well, while we're looking at that, you guys count pins. I got to pull up a diagram. So I need this thing. Hang on, I'm just going to dig out one of my pictures of this, diagrams of this. Is this the right one? I mean, maybe I'm not even using the right one in my schematic. You know, maybe I'm not even using the right one in my schematic. Who knows? I could be doing this all wrong. Well, let's have a look at this. Is this the right one? This is from Components 101. Well, this ain't it. What is this? This is what I'm using? Yeah, this is what I'm using. But it's backwards. So the USB is down. Where's the pin 8? GPIO 23, 22, 1, 3, 21. GPIO 8. So it's on the left side, third from the top. Hang on, I gotta get some pointers. Left side of the USB, third down from the top. That's so 7 and 8 are actually used for SD. Where the heck are these pins going? Oh, I said I did it again. These two are going. Up here somewhere. Maybe this isn't the right one. Maybe I'm looking at the wrong one. I could be doing that. I've done that before. Because there are, in fact, a couple of different ESP32s out there when you go looking to try and figure out what you're doing. No, it's not that one. I should almost use that one, it'd be easier. I think I have more of them. So I'm just looking for different pin out. There it is. Is it this one? This is the actual Node MCU 32S. Whoops, where'd it go? There it goes. Let's see what this has to say. Come on, zoom in. No, that's all we're going to get. Copy image location. There, that's not bad. Okay. So, where's D8? Yeah, it's over there. I'm definitely using D8 because this is the touch. We look at the actual pins. Touch is so we got IRQ out in so touch CS is 1, 2, 3, fourth one down. Sorry, I hit my camera, didn't I? Anyways, all of these blue ones are actually going to this. Yeah, this is it right here. So the touch CS is right. It's pin number 8. It's this one right here. So if we go back and look at my at this is wrong. Where's pin 8? Let's go back to the schematic and see what I've connected wrong. Should be connected to, where the heck's the pin 38 and 19. See, this is wrong right here, touch CS. So I've got it listed on IO32. Yeah, see, I screwed that up. I put it on pin 7, not on IO32, so that should not be there. Where is pin 8? IO8. You should have been. This one right here, sensor VP. I don't know why it's got that name, sensor VP. I think that's it though. SVP. No, I don't think it is. This isn't the same chip, is it? Where is So I am just wondering what's going on here because something's not right. Oh, hang on. Oh, hang on. No, hang on. That's the right one. How many pins are on here? 38 pins. No, that's right. No, that's the right one, but why is it wired up so weird? Did I make some changes since then that I didn't record? I've done something horribly wrong. So, okay, well, let's go figure this out. So according to this one, this is laid out according to the same way, the same pin out structure as the physical board. And the USB port is between pins 38 and 19. So the USB port on this design is down here. And just to make things easy, mine is flipped like 180 degrees, so. And you know the worst part of this is that somewhere, I actually lost my notes, my piece of paper where I had all my pin mappings that I wrote out in a nice little chart. I don't know where it went. I really don't know where it went, and it's annoying me. But wait a minute, I might have a copy of it somewhere, because something is not right here, and I don't understand why those pins don't seem to be in the right place. This one here, this touch, should not be going across the board over there. Maybe I have moved it since then. Anyways, let's go ahead and just put it on pin 8, wherever the heck pin 8 is. Where's pin 8? Oh, that's what started this whole rant, wasn't it? I was trying to find pin 8. Where's IO 8? It should be over here on pin 3. No, wait a minute. It's right beside it's 3 down from the USB on the left side of the USB, so it should be this pin right here, SD1. Okay. So I've got SCL and SDA up here. These are the two that are used for my real-time clock. They're in the right spot. The real-time clock is over here. Okay, that's just ground. That's 3.3 volt. So SDA and SCO. Yeah, and it's these two wires. If we're looking on the NVIDIA, we go to this camera, we can see that the real-time clock is down here, and it's using these two wires, these two beige wires. And they are going to the right places. Okay, so they're correct on here. So it's just that I moved that touch for some reason, and I don't remember moving it, and it's not right on here. So where is, it's got to be SD1. Why is it listed as SD1 down here? It should come out up here. See, that's what happens when you're dealing with, when you're working with symbols from libraries, you know, you got to make sure that they are in fact right. You download somebody else's symbol and you don't pay attention, and you're suddenly, you think you've got one pin connected to somewhere and it's going somewhere else, and you're in debugging heck. So what I'm looking for is just something that quantifies the SD nature of those particular pins. Why? It says here, do not use D6 to D11. Pretty sure I'm already using D8. My Bluetooth button is on 27. And my touch is on pin number 8. So whatever. I'm going to go look for another diagram and see what I can find. This thing is called a node. MCU ESP32S. I'm just looking for a better pinout image that matches up with what I'm seeing. So this one says it's GPIO 8, yeah. Well, where does that other two words come from? SD0 and SD1 and the clock. Why? Is that some strange old second bus down there? What's going on? Somebody who's watching, tell me what's going on. I just need closure on these two pins down here. Why they're called SD0 and SD1? Where are they really pins 7 and 8? What's this one? Oh. That one's more interesting. Nope, not that one. Yeah, see, that one's interesting. That one's got some information on it. I like that one. What about... See, none of those are right. What's this one say? No, that's the one I keep looking at. That's the same one. Why is it so hard to find the proper different internal? Yeah. Maybe I shouldn't be using that pin. Maybe I should, in fact, be using a different pin. But I think it's fine. I'm using it. I'm going to use it. You know what? I'm just going to use it. Screw it. Okay, so let's take a wire from pin here out to there. And let's take my label. I'm just going to move my label down here. Good. And I need to put an X. Where's my X? Oops. Where's my do not connect symbol? There it is. I need to put one there, there, and there, there. Just want to close these off as is best practice, right? Okay, so that's all of them. Okay, so let's update the net. Pop back over to here. We'll do an update. There. See, now that moved that net back over there where it should be. Now that makes much more sense, doesn't it? Where is it? Well, that can't be good. Okay, no, it did connect it to the right place. Good. Well, that is going to make things challenging. So let's just put that right there. I'm just going to move all of this stuff over a bit, just to give me a bit more room. There's no harm in that. Yeah, let's see there. So this whole line is going to move too, eventually, but not right now. I think I'm good like that. Let's pop over and see what this thing is doing to me now. Okay, so now what I really need to do is change the way all of my paths and whatnot, like the size of them. Now, what the hell do I do that again? I keep forgetting every time I come in here. No, that's not the one I'm looking for. Where is that option? Why do I always lose it? Manage libraries? No. Preferences? No. Tools? the button I'm looking for? No. I keep losing it. Is it one of these? What I'm looking for is that big dialog box that comes up and lets me change all the defaults of my traces according to the net that you place them on. Where is it? I keep losing it. And that's one of these buttons. No, it's not one of those. It is the no, it's not. Oh, no. 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 It's not in the view. It's got to be. So this is the new Kicad. This is Kicad 4. And I think this is actually the first time I've been trying to do some new things here with Kicad 4. I think I originally built this in 3. It's been a while since I've come back to this. Let's see, bottom copper. Wrote. Yeah, see, I want to change the size of those. Where is my default box? Not the footprint viewer, not the footprint editor. Those are zoom buttons. I don't care about them. What the heck is this? I don't want that. Go away. My design roles. That's what I'm looking for. Where are my design roles? Did things move on me? No, see, I want to know where the heck do I set my trace widths, my default. Where is that dialog box that comes up when I want it to? It's not under preferences. No, this is all weird stuff. It's none of those. Legacy toolset? Modern toolset. F9, 11, and 12. Those are interesting. What do we got going on here? That looks better, doesn't it? So where do I set my all my design rule options? I'm really hoping somebody starts typing and tells me, because I'm never going to find it. Oh, that's not it. Nope, that's not it. Okay, this is bugging me now. This is really bugging me now. It must be this. They must have changed it. Because this is not how it used to look. But this must be it. So yeah, this is weird. And I can't change it here. So where do I set these? This isn't what I want. This is close to what I want, but it's not what I want. This definitely ain't it. Okay, this is just driving me nuts. Configure paths? No. No. Well, I'm just befuddled by this. Where is that option? Is it over here now? No, this this is just all the basic stuff that should be there. Yeah, nothing going on there. Got my layer list. Ah, this is driving me batty. There it is. Well, finally. But this is definitely different. Oh my gosh, what is this? Okay, yeah, they've changed this. So this is going to take me a minute to figure out what's going on. This is all what's new with, this is Kicad 4 something, 5. Yeah. So I actually haven't been using it in a while. I originally did this design work in 4, but then it did the release. So this is going to take me a little bit to sort that out. Track width, okay, 0.2. I can just go ahead and change it here, which is kind of what I was hoping I could do. All right, so I want to change my track width. I'm just going to take a screenshot of all of that, of this particular little box here, so I can maybe come back to it if I need to. Okay, so I wanted to change my track width to, what was it, 0.4. I want to change my via size, my via drill. No, that's right. Well, just my track width needs to be a lot bigger, but the via size, I better change that to about 0.9. I'm using a 1/2 inch drill, so I like to make the actual drill hole slightly smaller than the drill bit I'll use. In fact, I'm going to be doing these in small print holes anyway, so yeah, that's right, that's right. So I'm going to go with a 0.4 millimeter track width, just to see what that does. No, I want to go much bigger than that. I want to go way bigger than that. Well, that seems better. Okay, so this is on the bottom of the board. I need to run a trace kind of like that. Come on. Yeah. Okay, I think that's a much better trace line to use. Let's see here. Because this is what came out of my first print job, and that's just way too fine to use, so let's maybe go with, you know what? Nah, let's make it bigger. Why mess around? I don't want to cause myself issues. So I think the last board I made, well, one of the last ones I made. Let's have a look at what this looks like. So those are pretty wide traces, right? So I'm not afraid to make them wide, just to make my life easier. This is a homemade circuit board we're dealing with, so I don't need to impress anybody with these design sizes. Still working well. God, I love this thing. It is just so awesome. Let's leave it there for a while and see what happens. Let me know if it crashes. Okay, so I'm going to go back here. I mean, I'm actually going to change this track with like 1.3. Change my via size to 1.3. The drill size, I'm going to keep it at 0.4. There we go. Now I'm going to move this thing. Like I said, I'm not afraid to give myself room. This is just a homemade board. It's really just a whole prototype. So there are second revisions and third revisions that got to come. For example, a further revision I'm going to have to make on this circuit board later on is I want to add, if you look on these TFT boards, these TFT displays, right, these beautiful little displays, you can see a second set of holes up here. So you can actually add another set of pins, and that gives you SPI access to an SD card. Now, it's not an entirely fast SD card, but who cares? A further revision of HardSense is going to include access to this through these pins, and that'll be used as a wallpaper. Albeit you can put images, pictures on an SD card, load them up in here. So as a screensaver, HardSense can pop over to an image displayer, and you can have all your images flying by. So that's one thing that'll be adding. But that's a further revision down the road that will happen. So this is just a homemade board, just to get everything up and running as an early prototype. We'll redesign this board to be prettier and whatnot. So I'm going to go with big fat traces. It's going to make my life so much easier with making the board myself. We can take a look at this one. This is a dual-sided board this is a simple breakout board. But yeah, I tried to use big fat traces on it as well. You probably can't even see that, but come on. Or maybe it's easier to see that. Anyways, let's get back to work. Don't forget to subscribe to the channel if you haven't already. We'll do lots of interesting things. Okay, so I just want to move this one down and out of the way as well. I don't know why there's this extension on here. Let's just delete this. Come on, click. Why won't you click on there? Thank you. Now just delete. Thank you. So I'm just trying to give myself some room to work. But this will, in fact, mess up the 3D viewer. It's going to complain. But I'm okay with that. I don't know if it's like that. Will it actually pick up other changes? Let's see if I move this just down here. Yeah, it still picks it up, but it gives me an error, so I don't have to worry too much about that. Let's just get everything into place. Okay, I want to move this. I'm going to actually move it down like that. There's a good spot for it for now. And I'm going to move my capacitor out in a bit. And then I'm going to take my power connector I just want the 3 volt. Can't I just have this? No? You're not going to let me just have that? Okay, fine. I'm going to put this back to where it was. Or maybe actually I'll switch it to this side. And then just put the power back over here. Yeah. Okay, good enough. Bring a trace, big fat trace. See, now that's nice. It's almost the same size as the pad. So now I can get my drill, when I drill the holes, I can be off just a little bit, and I can be a little bit sloppy with my soldering, and I know I'm going to be good. So it's nice to build a slightly fatter line. Okay, now we've got a second ground line and a power line. Oh, wait a minute, that's a 3.3 volt. The ground just connects straight across, and it goes, where does it go? Way up there. How did I do that before? How did I do that before? Just move that out there. Let's move this down here. So with the ground lines and the power lines, I don't really want to have them going too many different weird places, so I'm just going to try and do that. I like the way you were doing it before. Come on, like that. That's a good way to do it. What do I want to do there? I don't want to do anything fancy. Whoops. Whoops. What's the hotkey for that? Track. Add new track. X? Really? I thought X was the other one. All right. Okay, let's put that there. Put that there. Whatever, good enough. Okay. Now I got a 3.3 volt. Where the heck does that have to go? Let's put it. Let's do this. Yeah, right there. Nope, that's not going to work. Nope, it's still too close. Let's put it there. This one has to come here. This one comes here. Say there. Oh, and I need a ground line. That's fine. Okay. Why is that one connected? Oh, that's why, because it's not connected anywhere. Okay, here's what I want to do now. Let's just delete this. Let's take a line from here. Let's do that. Let's delete these, because I need. What am I doing? Let's do this a different way. Let's get rid of that. Let's get rid of that. Let's get rid of that. Let's take this and do that with it. And then we can take this and move it right there. Now I can take my ground line, run it like that, take my 3-volt line, and just for the sake of, why won't you do my thing there? Put it the other way. Yeah, let's put it this way. Let's move it over there. And then let's take this line, put it there. Now I can just run my ground. Oops. From there to there. I can run my power. From there to there. I can run this ground line. No, let's run the power line first. Say to there. To there. Where am I going with it? Right there. Okay, that's not entirely pretty, but I'm going to deal with it for now. And then I'm just going to take this ground line. Like I said, I don't mind if I'm making my board bigger than it really needs to be. I'm perfectly okay with that. There. Now I can take these lines. Okay, I might have made my, alright, you know what? I'm on to this. This is going to work. Okay, I got the right idea. So now what I want to do, get rid of those. I'm just going to take this. I'm going to move it out of the way. Well, I need to take this one first. Okay, yeah. Take a line from here. Right to there. And then bring this one down the same way. Too close. That'll work. That'll work. Good. Now I can move this into place, say right about there. That'll work. Now I can run my 3-volt line. Nope. Come this way, thank you. Keep coming this way for now. Good enough. Now I can just take this line, bring it down here. Give me a nice little, come on now. Why won't you give me a nice little click there? Did I just do a bad thing? Yes. Come down to there. Now give me a nice, thank you. Now I can run this line up to here. Whoops. I wanted to run this line first. Yeah, good. Put that up to there. Turn that in. Now I can run this line up to here. And in. Okay, good. So that takes care of that. Now this one, I'm going to run it straight out. What? Via. V, okay. Why was I thinking VIA was on X? Okay, I want to run my wire out this way, right to there. I'm going to put a beautiful little VIA in there. Wait. Will you flip layers? I thought it was, when you're laying a via, or when you're laying a layer, I thought you could just press the same X key. Yeah, see, to do that. Because now I can just bring this all the way down, put another via here, get back onto, come on. There. Oh, see, it is the V key. Good. Now I've got my button connected. And I got all those lines that are happy. Perfect. I think that's pretty good. Now let's go ahead and, what the hell? And let's bring this wire back in, or this border back in. Come on. Okay, right about. I don't really like the way this thing zooms in and out. It doesn't really zoom the way I think it should, or where I think it should, or when I think it should. Okay, let's put this line right there. Okay, good. Now let's move this one, if I can. Come on, click. Okay, that was hard. Now, I don't want to move this one, I just want to extend it. So please be nice to me and I just extend. Hey, I did it. I think I even got it in the right place. What's my Y coordinate? 116.205. 116, I got it in the right spot. Okay, now let's bring, I think we're good there for height for now. I'm just going to bring this one down and connect it to there just so that, and this one too. But just to stop the 3D'er from complaining. Oh, nice. Okay, so that's good. Well, that's not going to work. I wasn't even paying attention that I got it that close. But that's fine, I can actually just move it up. I can just do this. It doesn't have to be that close. I really wasn't paying attention, was I? I can move it up to there and still get away with what I want to do. Perfect. And I'll take my, where do I want to put this? Okay, now let's route my wires again. This way. And then this way. Why did you do that? Okay, why are you doing this to me? Don't be weird. Don't be weird. Why are you being weird? Thank you. Now I wanted to run this one up to right about there, and then in, and this one, say there. See, that's the beauty of Kicad with its 3D rendering abilities. You can just catch things like that so much easier than, you know, I didn't even notice that I'd run that drawing over it, but here, this was obvious, eh? So I'm okay with that. I like that sizing. That'll work. Now, for the tricky bits of this side. All right, what do we want to do here? This looks like a pretty easy one to deal with. I'm actually going to move this one a bit closer. Say there. Now let's just throw in some traces and see what happens. Come on. There we go. Now this 3-volt line, I'm going to run that out here. Down here. let's say, just click there for now. There. Where do I want to run that up? Do I want to run it all the way over? Yeah, why not? And then I've got a ground line conveniently located right there. Okay. So I connected those two ground lines for some reason. Why did I do that in the schematic? I think I did that just to make my life easier. I should have actually called. I got ground A. Where's the other ground? Ground and ground A. Ground, ground. Volume encoder is going to ground A. The button's going to ground A. So why are these two connected? Oh, they're connected internally. No, that's ground 2. This is ground 1. Why do I have this connecting those two grounds? Something is amiss. Oh, that's why. Okay, I need to remove one of these. Which one is going to the real-time clock? Ground, ground. Okay, so ground, I need to actually remove ground from this. That sucks. I should do that the other way around. Now, if I generate my net list again, reload my net list. Yeah, see? Something bad happened there. Why did I do that? Oh, that's why. So it is, yeah, shoot. That was definitely a bad change to make. What I need to do let's put that back to rights. Okay. That should have worked. I need to remove ground. I really need to remove ground from this. Well, that sucks. I kind of like to keep ground around. Now this should break that link and not break anything else. See? Okay. So I got that one done. Now we're going to go ahead and, how are we doing over here? Just wondering what my graph is doing. Let's have a check-in. So what we're seeing here is just some graph of my processor usage while I'm streaming and working on the software. Let's get a closer look. This is my GPU screen for HardSense. Wow, it's definitely using up a lot of my CPU for all of the streaming work and Kicad work. Let's have a look at our home screen and just see what is generally happening. Nice. And what about our GPU specifics? So that's interesting. The core clock on the GPU is almost 50%, but it hasn't actually moved. The core load. That's what we see here. That's the load. But the core clocks have not moved from the really low setting at 608. So I mean, they're hardly being used at all. So seeing a 50% load on the GPU, but only a 608 megahertz clock speed, you know, it's not a load. Well, let's go back to the home screen. All right, back to work. We're almost there. Okay, so let's just do this. Let's put a line from there to there. Just do the easy ones. And then we'll see what we might have to do for the next step. Okay, so that works there. This thing, let's put it there because it looks like a couple of those wires line up. Okay, that one there. No, see, this is nasty. Let's move this somewhere else. Let's try that. Whoops, where am I going with this? Where the hell am I supposed to go with this? Oh, well, this one goes way up there. This one goes down there. Oh, okay, so that's interesting. So this will be fun. So you know what? I want to go... I want to take this one to here. Nope. Nope. Okay, I'm going to have to do that. What the heck is this? 21. Where do you go? Oh, you're going to there too. Okay. And you are going up there. Well, you go down here. Okay. Let's put you there. Okay. And let's take this thing. And just get it out of the way a bit. So this is just the first run. It's just going to give me an idea of kind of what the traces are looking like, and then I can go back and refine them, or, you know, as we call it, refactor them. So don't worry too much about how ugly and gnarly they are. I'm just trying to see where everything's actually going. Okay, so this 3.3 volt has to go all the way around. That's right. Okay, now we got a ground up there, and this pin. Okay, that one takes care of that. This one goes right there, so that one's good. Okay, now my touch pin has to go way up there, so I'm going to bring that out to here. And then bring that up to here. Say right there. Now I got a ground pin, and this one. This one should be fairly easy because I can actually just do this. Put a via there. Run it all the way down. You give me a straight line to there. Put another via in, and that's connected. Now that ground pin, I'm not happy where that ground pin is. So what I'm going to do is I'm going to remove this one. I'm going to do this ground pin to there. Okay, I need to move this one too. Okay, let's get rid of that. And let's put a line from here to there. We're just going to run that straight down with a via there. Now, this one only has to come out to there. Put a via in. Oops. That comes up to here. There we go. Connect that. Oh, I still got this one. Bring that out to here. That's what I was going to do. And then put this here. All the way down to there. Put a via in there. And we have a less than pretty board. Now let's just take this. Move it. There. Come on, move this. Come on, click on you, please. Oh, what's this? Oh, that's for this. And this, that's just a label, right? Yeah. Yeah, that's just a label that's on there. Okay. Come on, click on the darn line, please. Thank you. Oh, that's not going to work. Why won't you click on the line? You don't, just go away. Okay, now I need a new line on my edge cuts. Now let's just take this thing, try and click on it, please. Thank you. And I want to just drag you right out to about there. Now I'm going to add a new line and hopefully it connects to you. Thank you. What are you at? So your X is 105.41. Right there. That looks like a good spot. What was my Y here? My Y value is 53.975. So I want to connect to this at 50 right there. Good enough. Now this line, if I can grab it, delete it. This line, if I can grab it, please grab it. I'm not going to delete you. Don't be shy. I'm going to shrink you down to there. Now this line, be nice, thank you. I'm just going to move you right up to there. See, that wasn't so painful, was it? Not at all. moving all my edge cuts so that I got something to deal with. Come on. Come on. Please click on the line. Thank you. There. Let's go see what the 3D looks like. I can live with that. I can live with that. I certainly can. Now, one last thing I want to look at. I just want to see how actually big this is. So from here to here is 6 centimeters by 5.5 centimeters. So let's have a look at how big that is. I don't have a ruler with me. So that's 6 centimeters by 5.5 centimeters. So one of these TFTs is, well, that's 5 centimeters wide. So this board will be just a bit wider. And this is, what, 6 centimeters long. So the final board that I just made there will be about that big, and that's fine. I mean, it's still smaller than the TFT. So, well, about the same size. So good enough. Let's have a look at what we got going on here. I guess we can move this in a bit. Actually, you know what? Let's do this. Let's try and grab this one. And move it straight over to about there. Save that. I think we're golden. You know what, I think that's good enough. I don't even think I need to really worry about changing anything. Yeah, I think we're fine. I think it's absolutely fine. So you know what the next step is? The next step is to export these into a printable format that I can use to actually print out onto a transparency to actually take the next step of making these. So what I want to do here is I'm going to go into my HardSense, Hardware, Kicad. So this will be the folder I work in. Okay, good. So I want it up here at the top. I'm going to go on print board, and I want to print just the back copper for this one. I want to make sure my edge cuts is selected, and that's it. I want to change the real drill to just a small mark. All of this is fine. We'll just take a print preview, and we can see how that looks. So that looks pretty good. I like that. That's going to look wonderful. You can see how big those traces are compared to the pads. So yeah, that'll be much easier to make. So here, now we go to print this to a PDF, and I'm going to save it in this working folder. And this is, what is this? This is the back copper, the bottom copper. That's a PDF. Now we're going to uncheck that. We go to the front copper, Leave everything else the same, except we want to mirror this one. So we'll print that as mirrored the same way, but we'll give it a different name. This one will be top copper. And we're done. So now, what I'm going to do is I'm going to open up another program called GIMP, which is my photo editor. It's free, but it makes this next step actually quite easy. What I'm going to do in GIMP is I'm going to go to Open, and I'm going to go find that top copper file, or the bottom copper file that I just saved. Where am I? Kicad. There we are. So in here, I'm going to open up top copper. No, sorry, bottom copper. I want to do bottom copper first. Now, when we click open, on this box, you see how it defaults this resolution to 100? We can leave everything else the same, but change this number to 600. 600 is a good number. It's just some numbers I played with. Bigger didn't really seem to make a big difference, but 600 is a good number. But remember 600. So we're going to import that. Now we're going to go, oh, shoot. I got to go back to the we can close this, we're not going to need it. I got to make a change on here. Shoot. These are too thin. I want to change these to, let's say, 2 millimeters? No. 1 millimeter? Yeah, let's go with 1 millimeter. We need these to really stick out when we actually do our design, or I do the print. So I think 1 millimeter is what I normally use. Let's have a look at what 1 millimeter look like. Bottom copper, print preview. That's definitely better. Let's go with that. So bottom copper, edge cuts, small mark, PDF, bottom copper. Now we pick our front copper, make sure it's mirrored, and then print that. Front copper, that's my top copper. Okay, now let's go back to GIMP. We'll reopen that. Top copper, or bottom copper first. Resolution is 600. Yep, that looks right. Now let's open up the top. Import. Okay, so now on our bottom copper, I'm going to just go ahead and select this. Actually, you know what? Shoot, I did it again. No, this will work. Nope, I did it again. I'm going to go back and export them for the third time, but this time we're going to do it portrait mode. And okay, so bottom copper, normal, edge cuts, print, bottom copper, front copper is mirrored, print, this is the top. Okay, we're done with that. Let's go back to GIMP and close these because we don't need them. Reopen them. Resolution is 600. Import. I really wish I could just remember to do this the first time all the time. Open the top copper. Okay. Import. Now what we want to do, so I'm going to zoom in a bit. Make sure we're at the top. I'm going to go ahead and make a selection around that and hit Control X. That cuts it. Now I'm going to paste it back in, but I'm going to move it now. I'm going to move it up towards the top. I'm going to give me a bit of a border around it. I don't need much of a border on these sides because I'm going to put a second one in, but it's nice to have that border. And this is going to help me on the next stage when I actually go to make the circuit board, having this gap up here is really important, which I'll show you during that step. So we're going to paste another one and just put it over here. Don't need a big space on the edge, so that's okay. We're going to put it down. Now we got to get rid of this, otherwise that'll just come out as a big black spot. So on the left, I'm going to pick my pencil, make sure my size is nice and big, make sure I've got white selected as my color, and I'm just going to color that in. Select again. Now I'm going to go to my other file. Oh wait, I did that on the wrong one. You know what, it doesn't matter. You know what, it does matter. So we're going to do all these steps again, but on the right file this time. This is the bottom copper file. I always like to work on the bottom copper file. You'll see why. So I'm going to cut that. It's just, I like to have my bottom copper to be at the top of the page, and then the next one I'll paste on here. So I'm going to make sure there's a nice bit of a spacing there. Good enough. We'll paste another one kind of beside it. Good enough. We'll fill in our little spot down here. Go back to our select. Now we go to the other one, and we're going to select this one, copy it, go back to our first one and paste it. We're going to put it down here. We're going to give ourselves a bit of a nice gap around it. Maybe a little more. There, that'll work. And then paste this one. So this is our top copper, and that's our bottom copper. We're going to save that just like that. Now we'll go back to File, Export As. We're going to call this both sides ready to print. And I'm going to export it as a PDF file. Make sure it's called PDF. And we'll export that. So this pop-up box, just let it go, just say export. Okay, now let's go back to just a web browser here. Open up a new tab. Now let's just open up that PDF file. There it is. And let's print it. But this time, we're actually going to print it for real. You should hear the printer starting any moment now. There it goes. So there it is, my printed circuit board. Now the next step, I'm just going to actually test fit some components to make sure that, oh, I touched it again, didn't I? It's going to be nice that when I stop touching and shocking it, it gets turned off. The next step is just to actually take some of these real components and then just line them up on the paper to make sure that everything really is sized right. You know, you want to make sure that all your pinholes really are the right size and nothing got messed up on the printing. Doesn't look like it did. So that's my final circuit board. Now the last step I'm going to do is I'm just going to inspect this, make sure there's no errors. Everything's going to look good. So now I'm going to keep this, and as long as I'm happy, I'm going to do another print onto a transparency. And then we'll use that transparency for the next step. And there we go. That is my circuit board for phase 1 of HardSense. Sure, it's not pretty. I mean, these are pretty fat traces, but like I said, this is just to get the prototype up and running on a homemade circuit board. I like to have the fat traces. It just makes it easier to make one of these circuit boards, you know, by myself. You're less prone to make a mistake when your traces are that big. So it makes life easy, and it doesn't have to be pretty or laid out right. A later revision, when I come back with the with some additional changes, and we'll probably send the board off, once it's properly made or designed and a finished revision, and not just such an early prototype. Then I'll go with the smaller traces that are a little more care with the layout, and then send it off to a fab shop and get a bunch of boards made. So that'll be cool, but that's not going to happen for a while. I am happy though that I did actually manage to get this whole thing remade, or made and ready to be actually turned into a real printed circuit board. So the whole process takes just a couple hours to do. So I'm hoping I'll do a live stream of that Thursday, and that will be the next step of actually printing this onto the transparencies and turning it into an actual physical circuit board, followed by printing all of the little components onto it. That's going to be awesome. So there's HardSense, the touchscreen, just running away, doing its beautiful little work, and it's about to have a circuit board, and that's going to be a wonderful step, getting it off of this breadboard, and the way it's all plugged into everything, having it on a real life circuit board is going to make life so much easier to do some more development work with it. Anyways, I think that's going to be a good place to call the end of the stream. I will be checking all of this in, so you'll be able to, you know what, actually, I have to make a couple changes before I can do that. Let's take these towards Git, delete. Going to add these files. Now let's go ahead and do a commit to this branch. This is branch 20. Nice. And then what I'm going to do is swip over to this, and I'm going to go to just a top view. Nice. File, export current view as a JPEG. Where did I want to put this? I want to put it at this level. Just want to get a couple of angles of this. File, export as JPEG. We're going to call this one 2. And then maybe get another view from here. Sure, why not? Call this one 3. Now, let's add them. And we'll go ahead and commit this. So there you go. You should be able to go ahead and check out branch 17, or sorry, branch 20 of my GitHub repository. We'll go to HardSense. I will merge this into master after I've maybe just done a few more validations to make sure that there's no problems with this. So we have a look. We got software, hardware, Kicad. These are the images that I just checked in that you saw me just take. So everything's up there, ready to go. And like I said, I'll be merging this into master of my GitHub repository. That's github.com/kitecraft. And then there's HardSense. And of course, if you actually want to use this circuit board, you're going to need my Kicad libraries, which can be available from my repositories. There's the Kicad libraries right there. So that's it for me. yeah, that was a good stream. It was nice to get that circuit board done and redesigned and ready to go. Can't wait to get that onto an actual board. And so this is me signing off for the night, saying thank you very much for sticking around. I appreciate you watching. By the way, today is 104 days without a cigarette after 35 years of smoking. 104 days without a cigarette. That's why I've been chewing this nicotine gum. Okay, y'all. Thanks for watching. And I'll catch you on my next stream. Might play some video games tomorrow night, play some Black Mesa, and then do the circuit board making on Thursday. Come on. Why won't you switch? Oh, more down the home screen, huh? There we go. Okay, say goodnight, y'all. Good night.
Shut up and sit down.